Hello and welcome to another video AI of finding centroids. This time we're finding the centroid of a symmetric composite shape, very similar to the one in the symmetric shape centroid video AI that's also available. This time though it's got a couple of, in fact 3, pieces that have been cut out of that shape. Given a cross section, we still need to find that center of area. And we're going to use our two basic equations for finding both the x and the y distance to the centroid. We need to establish a coordinate system, and we need to choose a common point of origin or a reference point. Again, noting that this is a line of symmetry along this y-axis, we choose to place our reference point at the base of that line of symmetry, knowing that our centroid of that composite section will lie on somewhere on that line of symmetry. We also choose to place it at the base of the shape so that all of our y components of the centroids to the subshapes are positive. We notice that we have 3 rectangles, and we'll label them as shapes 1, 2, and 3. And we have 3 circular cutouts, and we'll label those as shapes 4, 5, and 6. Using our equations to establish the headings of a column, or of a table, we know we'll need to find the area of each piece, both the x and the y distance to the centroid of each piece, and then we'll need the product of those distance to the centroids times the area of each piece. So there we go. We have a table, and it's time to begin to fill in the table. Let's look at shape 1. Shape 1 is 10 square inches. Its x distance from the common point of origin is 0, and it is 1 inch up from that CPO. Shape 2, 15 square inches. Its centroid again lies on that line of symmetry, so its x distance is 0, and its y distance 4.5 inches from the common point of origin. Shape 3, 40 square inches, 8 by 5. Again, lying its centroid on the line of symmetry on the y-axis, its x distance is 0, and its y distance is 9.5 inches from the base. Notice that shapes 1, 2, and 3 are just the rectangles themselves. The area does not include the area cut away by the circles. We'll take care of that here now. Shape 4, it's a circle. The area of that shape, being a 1-inch radius, is 3.14. Now, since it has been cut out from the shape, we're going to put a negative sign on that area. It's negative area. It doesn't exist. It's going to be removed from the cross section. Now, it does not lie on this line of symmetry, so it has both an x and a y distance to the centroid. Horizontally, it is 2 inches to the left, or a negative 2 inches from our CPO, and it is 9.5 inches up from that CPO. Shape 5, another circle, again 3.14 inches of area, again negative because it's cut out. Symmetric to shape 4, it is a positive 2 inches to the right and 9.5 inches up from the CPO. Shape 6, a smaller area, just less than 1/4 of a square inch. It also lies on the line of symmetry, so its x distance is 0, and it is 1 inch up from the common point of origin. Notice that these columns here have been completed. They are just simply the product of the distance to the centroid times the area, both the x and the y distances. Now, in order to apply these equations, we need to sum the area to find the total area, and we need to sum these two columns. And there we go. A total of 58.5 total square inches of area makes up this symmetric composite shape with these cutouts. Now, applying these equations, simply substituting these values into our equations for distance to the centroid, the x distance comes out as 0 inches. Now, that x distance is measured horizontally from that CPO, so let's be complete with our answer and note that. The y component of the centroid, substituting in the values, comes out to be just shy of 7 inches, or just over 6 3/4 inches up from the CPO. Now, that puts it somewhere in this neighborhood, which seems reasonable. It is lower than the centroid of the composite shape without the cutouts, which makes sense because there is more area cut out on the top portion than on the bottom portion of this composite shape. And there you have it, finding the centroid of a symmetric composite shape involving cutouts.